In this video, I'm going to show you how to graph systems of linear inequalities. We're going to start off with this system here. Y is less than 2x and y is greater than or equal to x plus 1. And the way we're going to start off here is we're just going to focus on this first inequality, y is less than 2x. Let's go ahead and graph that first. And in order to graph it, we're just going to focus on the boundary first. The boundary is just the equality y equals 2x. So let's draw that line. Y equals 2x. So how do we draw that line? Well, this is like 2x plus 0, so y-intercept of 0 and a slope of 2. So over 1 up 2 and then over 1 up 2. And now let's just go ahead and connect these points. The only thing that we're going to do differently here though is because this is just less than, not equal to, we're going to draw a dotted line to indicate that equality is not allowed. So let's go ahead and connect this up, draw a dotted line here, and here we go. Here's our line. That's y is less than 2x. Well, that's y is equal to 2x, but we're going to make it y is less than 2x in a moment with our shading. We're going to shade on one side of this line, but we need to figure out which side do we shade on. Well, this line is y is equal to 2x, and we want it y to be less than 2x. So we want to have y less than this line. So y is lower than this line. Less than for y means lower than. So we're going to shade under this line here. So this is what we're going to be shading under the line. And there we go. There's our first inequality. Y is less than 2x. Now we'll deal with our second inequality here. Y is greater than or equal to x plus 1. And again, we're going to start out by drawing the boundary. Y is equal to x plus 1. So let's go ahead and draw that in. There's a y-intercept of 1, and then the slope is just 1x. So over 1, up 1, over 1, up 1, and so on. We continue that. Now when we draw this line, because it is greater than or equal to, equality is allowed. So we're going to make this a solid line to indicate that equality is allowed. Okay, so line this up and draw a solid line here. Here we go, solid line. And now this line, that's going to correspond to y is greater than or equal to x plus 1 once we shade it. Okay, so what side do we shade on? This side or this side? Well, now y is greater than x plus 1. This is the line y is equal to x plus 1, so we want y above this line. We want y to be more positive than this line. So above this line over here, and we'll just go ahead and shade that here. Okay. So now it is time to actually graph the solution of the system. And the solution of the system is where both of these inequalities are satisfied. So where both of the shading overlaps. We see that the overlap is right over here in the corner. So why don't we go ahead and shade that in? That's this corner right over here. And we'll just darken that in nice over there. So there's the solution. This system of inequalities corresponds to this shaded region over here. All right, here's another system for us to graph, and this is going to be very similar to the previous problem. We're going to start off by graphing each of these inequalities individually, and then we'll just shade where the solutions overlap. So first of all, this inequality y is less than 1 minus x. Let's just go ahead and graph the boundary. Y is equal to 1 minus x. So what does that look like when graphed? Well, let's go ahead and rearrange this 1 minus x. That's like negative 1x plus 1. So y-intercept is 1. That's right over here. And the slope is negative 1. So, okay, slope of negative 1, so that means over 1, then down 1. So the next point will be over here, and then over here, and so on. So let's go ahead and connect up these dots. And because this is just less than, not equal to, we're going to have to use a dotted line here to indicate that equality is not allowed. So here's our dotted line, and let's label that with our inequality. Y is less than 1 minus x, and we have to do shading here to indicate which side of this line contains the solutions to this inequality. So y is less than 1 minus x. Y is less than means y is lower than the line, because we want all the y coordinates that are more negative than the line. So let's go ahead and shade lower than the line here. So that's about over here. Okay, so there's our first solution to our first inequality here, and now it's time to figure out the solution to the second inequality. Now the second inequality, we'll go ahead and graph the line y equals 2 to begin with. We'll graph the boundary. Y equals 2, that's just like 2, well that's just like 0x plus 2, so 2 would be the y-intercept. And then 0x, so slope of 0, so every time we go over 1, we go up 0, so we're at the same y-coordinate, same y-coordinate. This is just a flat horizontal line through the y value of 2, and we'll go ahead and plot that. Again, since this is just less than, it's not equal to, so we indicate that it's not equal to by drawing a dotted line. So here's our dotted line, and we'll shade this dotted line to reflect the inequality y is less than 2. Which way do we shade? Do we shade above or below the line? Well, y is less than 2 means y is lower than 2 here. Less than, lower, shade below the line, shade the more negative y's. So, okay, just shading below the line here, and there's our solution to the second inequality, y is less than 2. So now it just remains to go ahead and shade where the solutions overlap. Where does the shading overlap here? Well, the shading overlaps in this bottom left section over here. So let's go ahead and try to shade that in as best we can. So there's kind of like the boundary. The boundary is these two bits of the two lines, and then we're shading all of this area here. So let's just go ahead and shade that in. So there we go. That is the solution to this system of inequalities. It's just that shaded region over here. Here's our final example. This time we have a shaded region, and we want to find a system of linear inequalities that represents the shaded region below. So this is kind of backwards of what we've been doing. Now we are given the shaded region, and we want to create our own system of linear inequalities that represents the shaded region below. So our system, let's just go ahead and write that over off to the side, and we'll have 3 inequalities that make up this triangle here. Now each of these inequalities that we'll have will correspond to one of these lines here. We've got 3 lines, so 3 inequalities, and we'll just have to decide what side of the line is the triangle on for each of these lines, for each of these inequalities, so that the shading of these inequalities would overlap to form this triangle here. I think the easiest one to start off with would probably be this horizontal line that passes through a y-coordinate of 2. So the equation for that, let's just go ahead and write the equation for that line. The equation for that would be y equals, well, what is the slope? The slope is just 0, because every time it goes over, its vertical change is 0. So 0x plus, what is the y-coordinate? Y-coordinate is -2. So 0x plus -2, well, that's just y is equal to -2. Okay. Now, we want to shade on the side of this line that corresponds to the triangle. So we want to be shading on this side of the line here. We want to be shading above the line. So what does that correspond to? Is y greater than -2, or is y less than -2? Well, remember, less than means lower, and we're not shading lower. We want to be shading above. So we want the y values that are more positive than -2. So y has to be greater than -2. Okay, y is greater than -2. Last thing, do we want equality in this? Do we want y is greater than or equal to -2? Well, we've got to look at the line here. The line is dotted. That means y is not equal to -2, which means that we don't want equality. We just want y is greater than -2. Okay, so that's going to be our first inequality here in our system. Y is greater than -2. Now our second inequality, why don't we use this green line here? So this green line, why don't we first construct the equation for that line? So y equals what? What does y equal? Y is equal to, what's the slope? Well, you go over 1, up 1, go over 3, up 3. The slope, the ratio is always 1. So y equals 1x plus the y-intercept. Well, it passes through the origin, so y-intercept is 0. So just y equals x. Okay, so that's the line, but we really want an inequality here. We want to be shading on this side of the line where the triangle is, the darkened in black triangle. And what do you think? Should this be y is greater than x or y is less than x? Well, we want to shade lower than the line, so we should have y is less than x. So let's write that down. Y is less than x. And last thing, do we want equality here? Well, look at the line. Since it is a solid line, we should have equality. Y should also be allowed to be equal to x. So y is less than or equal to x. That's going to be our second inequality, and we'll write that in here. Y is less than or equal to x. And finally, for the third line here, that's the vertical line here. So let's go ahead and write the equation for this line. Now, this line's a special line. Remember, vertical lines aren't in the form y equals something, they're in the form x equals something. So what does x equal here? Well, x is equal to 3. X is equal to 3, so that's just the equation for the line. X is equal to 3. Okay, so now let's turn this into an inequality. Which side of the line do we want to shade on? Well, we want to shade closer to the triangle. So let's go ahead, want to shade on this side here, shading left of the line. So how should we write this inequality? Should it be x is greater than 3 or x is less than 3? Well, we want the x values that are left, and that's in the negative direction. So we want the x values that are less than 3. So great, x is less than 3. And lastly, do we want equality? Well, this line here is a solid line, so yes, we do want equality. We want to let x be equal to 3 as well as less than it. So x is less than or equal to 3. There's our third inequality. Put that in our system here. X is less than or equal to 3. And there we go. We've got our system of inequalities that represents that triangle here. Alright, so now we know how to graph systems of linear inequalities. And in the future, we'll also see how to apply this knowledge to solve word problems.